Hello again. So in the last video, we talked about vectors, and vectors are important, but they're also kind of inherently limited because they can just store one type of information. So, I mean, you can have a vector of student names and you can have a vector of test scores. But what if you want, the student names and the test scores to be linked so that you can look and see that Gregory got an 87 on that test? Well, in that case, we need something other than a vector. We need what is called a data frame. And it's not exact, but informally, you can think of a data frame as a spreadsheet in R. So I'm going to show you a data frame. R has a number of built-in data sets. I'm just going to type the word penguins and I'm going to run that code chunk. And we see a very famous data frame. This shows up all the time in introductory courses. It contains data on penguins collected over a few islands. And you see that a data frame is basically a bunch of vectors sitting next to each other. So we've got a species vector containing the penguin species. We've got an island vector containing the island. We've got some numerical vectors, Bill underscore len, Bill length, Bill underscore depth, Bill depth, then flipper underscore len, flipper length. We've got a body mass vector. We've got a sex vector. We've got a year vector. And because these columns are vectors, if we pick a vector, bill length, for example, if we pick a column, I should say, all of the data in this column is the same data type. It's all numerical. It's all decimals. Except for this NA value that we see here. We're always allowed to be missing data, whether it's in a numerical column or a string column. We can always have NA for missing data. Each row then corresponds to a specific observation. In this case, a specific penguin. So the first row corresponds to an Adelaide penguin on Torgerson Island. Bill length 39.1, bill depth 18.7, zipper length 181, body mass 3,750, male from 2007. And I want to keep this lesson very conceptual because in a very real sense, you could say that an intro to data analysis class is just studying data frames. If we want to take this data frame and get rid of every row where we have missing data, we can do that. If we want to take this data frame and filter it, so we're only looking at Adelie penguins, we can do that. If we want to take this data frame and visually represent the average bill length for each species in the data set, we can do that. If we want to take this data frame and perform statistical analysis to ask if some of these species have larger body masses than others, well, we can do that too. So if I started talking about all of the stuff we can do with a data frame, we would be here forever because that's basically the entire course. So there are really probably just a few additional things that I want to say at this point. First of all, in this setting, in this R Markdown document, when I typed penguins, it only showed me the first 10 rows. Outside of that format, if I type the name of the data frame and hit enter, it's going to show me the entire data frame. Or rather, it's going to show me as much of the data frame as it can. You see, we've reached a maximum. There are 219 additional rows that it has not displayed. Well, in general, we don't want to visually inspect, you know, 500 rows or whatever, 344 rows. So one of the kind of default functions that we use at the start of an analysis is the head function. And the head function just shows us the first few rows of data, six in this by default. So we can get a basic idea of what our data looks like. We can say, okay, these are the columns, species, island, etc. This is what our data is. Um, Another thing it's important to be able to do is select specific columns from a data frame. And the way we do that in R is we type the name of the data frame, in this case, penguins. We type the $sign, and then we type the name of the columns. And let's store this as something. Island underscore vector. Now, if we look at island underscore vector, well, you see it's just that vector storing all of the island name. We should be able to create data frames. In practice, I would say probably in most analysis, the data frames come to you pre-created. Like if I want to do analysis on my grade book, I'm not sitting typing grades into R, I'm importing an Excel document into R, and my data frame will then just be there. But to create a data frame in R, here is the syntax. A data frame is just a bunch of vectors sitting next to one another. Um, at least in its most fundamental form, its most elementary form. So let's create some vectors. I'll create a vector n that contains two names, Gregory and Jeremy, and I'll create a vector S that contains two nums, 89, 93. And now I'm going to create the data frame, grade book. I type data dot frame, open parenthesis. This is usually done across several rows for readability. I'm going to create a column called student name. And the student name column is going to be this vector n. Student underscore name equals n. I'm going to put a comma. Then I'm going to create a student underscore score column, which will be this vector S. And that's all there is to it. When I compile this code, I've created gradebook, and now I'll type head gradebook in parentheses to look at the first few rows of my gradebook. And I see that I've created this data frame with student underscore name column, storing names, student underscore score column, storing scores. We don't have, I just did this to try to sort of drive home what's going on here. I give a column a name, and then I give the vector. I give the column a name, then I give the vector. We can also do this directly. Instead of defining n and s, I can say student name equals the vector Gregory, comma, Jeremy. Student score equals the vector 89, comma, 93. And this code does the same thing as the code I had before. It's going to create the very same data frame.